During the French Revolution, that's when the metric system took over. Hello, welcome to I Read This Book with Chris. This is Chris. This is the book. The Voyage of the Space Beagle. There you go. By A.E. Wimble. While discussing the Voyage of the Space Beagle, I will be drinking just some pour-over coffee. The question I want to think about while discussing Voyage of the Space Beagle is how much science should there be in science fiction? I have a very strong opinion about this, and it's different than other people's opinions about this. But I think this is an interesting test case to discuss. So what's going on in the Voyage of the Space Beagle? So it's by A.E. Wimble, who I'm quite a big fan of. Not everything, he's one of the people. I'm assuming it's a he. Wrote a lot of small books. I like small books. So originally it was published as 4 short stories that was then turned into this book. So the first one came out in 1943. 1943. Voyage of the Space Beagle is following this guy, Elliot Grosvenor, a scientist of the science nexialism, on board the Space Beagle. Apparently, humanity has sent out hundreds of ships out to explore things. Each ship has about 1,000 people, or at least this ship. It's about 1,000 scientists, and then some military men. And they go to different, they can travel faster than light. They go to different galaxies and planets, and they explore what's going on there. And our hero of this story, Elliot Grosvenor, is the only one out of the 1,000 who is a nexialist. Nexialism is the science of wholeness. He goes and he absorbs science, the scientific information and data and theories from other fields, and he applies it together. It's a new science in a lot of the older sciences. Like one of the guys he's butting heads with is a chemist. And chemistry is one of the oldest of the sciences that is its own individual thing that has a history of being a science for a long period of time. It's broken up into 4 different meetings with different beings, different civilizations that existed. Each one which does great damage to the ship and the people on the ship, and requires nexialism, this whole overview, to come in and to deal with and to solve this problem. It starts off, that's our guy. They were on a planet where it's a dead planet basically, but there are these creatures who they call pussycats who have tentacles, and basically they survive by going and killing other beings that are alive and eating their id, which they figure out is potassium. And so when they land on this planet, obviously this planet is basically dead except for these few guys that remain and a bunch of humans who are alive who have potassium in them. And so the giant cat goes and kills someone. They let it onto the ship and plays games and fights and kills people. The second challenge that the spaceship reaches is, as they are traveling through space, they are involuntarily joined into a communal psychic space mind from a species that has one mind that are psychically connected. It's a whole planet of these bird beings that communicate and are, one big space mind, and they reach out in a friendly manner to connect. And humans are not used to being connected psychically. Therefore, bad things happen until they're able to communicate with these people. The third story is about, as they are once again traveling through space, they have not landed on a planet. They are stopped. Their ship is slowed down. All of the energy from their nuclear transportation, whatever, is removed. And as they go to try to figure out what's going on, they see they are in an intergalactic space far away from other galaxies. They find a being floating out there who is alive. And this being is extremely powerful and can control matter and stuff with his mind. Super evolved is the word they use. And can take people's power, can kill people, and needs to capture humans, things that are alive, in order to make a cavity inside them and plant an egg inside them in order to create more of himself. And the fourth thing that they meet, the issue that the crew of the Space Beagle meets, is they are approaching a galaxy, and they find a bunch of, as they are coming in, once again, images are sent into their head, ideas, and everyone realizes it's some sort of psychic something or other. And they gather together for a meeting, and a bunch of giant creatures are teleported inside of their spaceship while they are still light years away from the closest anything. They end up realizing that basically the whole galaxy has been taken over by a sentient gas, which needs to live in swamps and gets its energy by things dying, and so has figured out the ability to do small space jumps, so it can go from planet to planet in different systems in its galaxy, but it's sort of trapped and needs to make a big jump to another galaxy in order to continue growing. And all of these problems are different problems which occur because the life that they find is different in some very interesting ways than the life that we humans might expect. When Columbus was coming to America, life was going to be different than life we expected, but it wasn't going to be beings that came and sucked the potassium out of you, or they weren't going to, as they approached North America, be psychically attacked and joined into their psychic commune, or any of those things. So it's strange and different in ways that are not theoretically impossible, but are unique and challenging to the way things are, right? And so I think it does science good. If you compare this to, say, a science fiction book that isn't supposed to be super scientific, like Hitchhiker's Guide to the Galaxy, there are not a whole lot of discussions in there about how different life forms could exist in a way that would be strange and weird, right? There are different life forms, and different life forms get their energy from different things. Like, one of the things I'm thinking of is there's a worm, which goes into your ear and survives. It gets its energy off of pulling in sounds and then translating it into your language. And it does that, and that's where it gets its energy to survive. And in no way whatsoever is that trying to be scientific. Is that trying to make a point? It's just a silly gag. Well, and here, it's like, these are different ways where life could be different in ways drastically different than we expect. However, there are some issues with this book, which any book that is trying to be over scientific. Our guy here, Elliot Grosvenor, being on a spaceship full of scientists, is going to do a lecture, because that's what all scientists love to do, is give lectures and watch other people's lectures, right? That's what scientists do. And so there's a little footnote here, which is the ship operated on what was called star time, based on a 100-minute hour and a 20-hour day. The week had 10 days, with a 30-day month and a 360-day year. The days were numbered, not named, and the calendar was reckoned from the moment of takeoff. There is, in a lot of people who like science, whose brain works the way that you kind of needs to be in order to be a science person, whatever that is, an idea that things should be better ordered. That the way that we have it, where we have 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week, 28 or 31 days in a month, and 365 days in a year. It's ugly. None of it works out. They want to have it make sense in the way that the metric system makes sense. 10 and 10 and 10 and 10 and 10 and 10 and 10. The issue is, the world doesn't work that way. During the French Revolution, that's when the metric system took over in France, and eventually it spread. During the French Revolution, they also tried to go to a different calendar. They tried to do a 10-day week, and was it a 10-hour day? They tried to mess with their hours and their days of the week. And it did not work. It was refuted by the people, and it only lasted for a few years. It may not make sense to someone who wants to order things. But the world is not ordered in that way for anyone to be able to do with as they wish. We have a 7-day week, and we have for thousands of years. We have months, and you either have 12 months, which are kind of awkward the way we do, or you can have a lunar calendar where you have 13 months, and then some years, and 12 months other years, but nothing ever is going to line up because the world doesn't line up properly. And I like things to line up properly, but I also realize when they don't, you just sort of got to deal with it. Let's see, next note I got. So they're sending out a bunch of spaceships, and about 50% of them came back, and about 50% of them were successful, and 50% of them weren't. Some of them, of the ones that weren't, some of them didn't come back, and some of them came back, but with hardly anyone left alive. And so, as a result, unknown to the men, all vessels had become proving grounds for sociological experiments. Nexialists, elections, split command. These and innumerable small changes were being tried out in the hope that man's expansion into space could somehow be made less costly. So the idea of A/B testing, different spaceships getting sent out with different forms of command, different things on there, is a very interesting idea. If you were to be able to send out hundreds or thousands of ships, and for whatever reason, half of them didn't return, yet you kept sending them out and people were still willing to do it, you would want a way to figure out to make it better, right? So that was a fun idea that I did enjoy. Let's see. This is when they're going through intergalactic space and their thrusters stop working. Their thrusters stopped working because this creature was able to sense it and pull the energy towards him in order to give himself energy. Because that's what he needs to survive, is being able to pull in energy from somewhere. But there's this discussion about instantaneous deceleration, which of course is a fun idea to have in a science fiction book until you realize it doesn't make any sense logically. I don't mean like it's like a science, like teleportation or FTL, faster than light travel, or any of these other things which are questionable, but there's an explanation behind why it kind of works. I'm saying if you have something which is instantaneous deceleration, where you can just stop, that works if you are like in a car and you're traveling along a street and you need to stop, and the moment you stop right there at that instant, because you moving in relation to the street, there is movement. But when you are out in space, everything is relative. There is no such thing. There is no difference between you traveling at a speed and you standing still and the rest of the universe moving around you. According to what plane of reference are you able to have instant deceleration? And if you are able to have instant deceleration, what that is that's just acceleration in the opposite method. But for whatever reason, these are two different systems. It's not like, hey, I have this way that I travel around, which is I can accelerate and decelerate in whatever way, and for whatever reason, that inertia doesn't come inside and throw around all the people in the spaceship around. In order to move, I need thrusters that are these nuclear-powered thrusters to move me through space. And then if I need to stop, I can just instantly decelerate, but that's not how. There is no ground frame of view which you are changing, which you are anti-deceleration from, because there's no ground view. If you are in space and something shoots past you, there is no difference between it shooting past you and you shooting past it. There is no neutral ground to view it from. Which doesn't mean there's an issue with the idea of being able to do it. It's a sci-fi book. You can do crazy things. It's just the explanation doesn't make any sense. Finally, there's this whole idea of nexialism, of having this one science which can solve things because it's able to take from every other science and put together, is an idea that I had the same issue with this book, although not to the same degree, that I had with the Foundation series, which is, there's nothing wrong with this concept. It's just Science can solve problems. Therefore, we have a science that has all science in it. In this book, it's nexialism, which is a whole. You consider all of science. In Foundation, it's civilization on a much larger scale with billions and billions and billions and billions and billions of humans. And so they have psychohistory, I believe. And it's, I have the equations which can be solved. And once you do that and you put all this stuff together, since I am the person who mastered this science, I can go and solve every problem. And that's not actually how science works. He was taking action that had never been taken before anywhere in quite the same way. He had used phenomena from many sciences, improvising it to fit his purpose and to suit the exact environment which he was operating. It was working as he had expected it would. His understanding, so sharp, so broad-based, left hardly any room for error. Science is a way to know things about the world, and it is done through experimentation and theorization, and then testing those theories and proving things out in a way to know things about the world. So there's this idea that these sciences can solve everything, that these science can... You can take all of these different ideas from all these different sciences and put them together and have a solution to your problems. You can have the knowledge of the world by putting all this stuff together. And those things don't work that way. Most things in the world are not things that science can solve. It's a little different in this book than in Foundation. It does not... This book I enjoyed. Foundation. I got through, I think, like the second book of Foundation, the Foundation series. And they're just about the scientist trying to solve a problem in the real world. This is about a scientist trying to solve a problem. It's more believable that dealing with scientists with scientific problems and problems caused by scientists trying to do things, that science might be useful. But if you're trying to use science to solve the politics of a giant system, of a empire that rules basically a whole galaxy in thousands of worlds, that's not something that science is able to solve, because that's not what science is designed for. I listened to the Bart Ehrman podcast. He is a historian who focuses on New Testament history, biblical history of that time. And he is an agnostic atheist. I don't know exactly, I forget the language he uses exactly. But he was talking about how, as a historian, history is designed. The study of history can figure out that Jesus was real, that he lived at this time, that he was crucified, and that a lot of people who followed him believed that he had come back to life. And this was a thing that happened, and that Christianity happened. But he was making the argument, because he used to be a Christian and now he's not, history cannot say whether Christ was resurrected, because it's a miracle. And by definition, it's of it being a miracle, and it's not something that normally happens. Historians cannot, because of the limitations of history set on it by the fact that, like, we're going to study history, they cannot make such a determination. And people who try to solve for Christ's resurrection using history are not doing it right. And if that is the view you have of history, I'm not saying it's right or wrong, but if you are saying history is about things that have happened, and because it's a miracle, that means it's something that we cannot know about, well, then you're not going to be able to prove it, because you're saying this is not something that history is solving for. Science can solve for certain things, but there's a lot of things, a lot of meanings that it can't solve for. And if you can recognize that science is not about certain things, it cannot tell you if a book, you can tell you, Albert Einstein figured out the theory of relativity, and this is the time he came to it, and all these other people said, oh, this is good. But history cannot say whether theory of relativity is right, because it's not physics. And it can go and say, this poet wrote this poem, but it cannot say whether the poem's beautiful, because beauty is outside of that. There's a lot of things that are outside of science, where that science, a lot of scientists do not appreciate, or cannot accept. Anyway, thanks for watching.